Hello everyone, this is Aditya. So in this project, we will build a model to predict the electrical energy output of a combined cycle power plant, which uses a combination of gas turbines, steam turbines, and heat recovery steam generators to generate the power. So we have a set of 9568 hourly average ambient environmental ratings from sensors at the power plant, which we will use in our model. So coming to the data set, the columns in the data set consist of hourly average ambient variables as quoted above. So we have temperature, which is depicted in T, and ambient pressure depicted as AP, and relative humidity depicted as RH, and exhaust vacuum depicted as V. Yeah. And we have this net hourly electrical energy output, PE, which we are trying to predict. Yep, that's our prediction which we are trying to do. Um, and coming to the modeling approach, so regression is the most suitable machine learning approach for this task, which I believe, since we are predicting continuous numerical value, and also since we have two or more predictor variables and one output value. So this is the best approach. Simple linear regression suits well when we have one predictor and one output value. So coming to the output metrics which we will be considering, so we'll pick mean absolute error, so which also gives the measures the average absolute error between predicted and actual values. I just shared the definition here. And the mean squared error, which penalizes large errors more than MAE, and R squared measures how well the model explains the variability. Moving to the next slide. So we'll get started with the linear regression model which I picked up first. So coming to the data set which I have received, I have divided the data set into training data, which is 80% of the data set which has been shared, and test data, which is 20% of the data which has been shared. And coming to the approach which I have taken, I have used Microsoft Excel as a tool to perform this linear regression model analysis. And you could see a snippet of the analysis which we have done, and also the table is given here which depicts the key output values of the metrics which we have considered. So the mean absolute error, mean squared error, R squared. So this is the values which we have got from the training data and the test data, and this is the bifurcation which we have taken. So similarly, we have followed the similar approach for the polynomial regression, and these are the values which we have got from a metrics perspective, considering the training data and the test data. And coming to the model comparison, um, considering the first metric, which is R squared, we have got 0.93 from our trained data and 0.92 from our test data perspective. So similarly, for a polynomial regression, we have got 0.88 from our trained data and 0.87 for test data. So it's clear from a conclusion perspective that considering the R squared, so linear regression has a better variance in both the data sets. Yeah. So similarly, for the next metric, mean absolute error, 4 for the trained data and 2.99 for the test data. Similarly, for the polynomial regression, we have got 6.46 for the trained data and 4.12 for the test data. So to conclude for this metric, so linear regression is better at minimizing the absolute errors. And for the mean squared error, the polynomial, given these values, it looks like the polynomial regression reduces MSC, but the cost is high in training the data when compared to the test data. Yeah. And if I have to conclude, so this is the conclusion which I can present for this project. So polynomial regression has higher errors, and R squared, which depicts relationships, are not captured well. And linear regression generalizes better with small differences in MAE and R squared. Also, the higher MSE on test data for linear regression may indicate some variance in the data, but polynomial regression doesn't seems to improve the generalization. So overall, I would like to conclude that linear regression is the best suited model for this project. Thank you.